Good morning, everybody. We are starting our next section of notes for C, properties of logarithms. So our learning are evaluating logarithms and rewriting logarithms by expanding or condensing using properties of logarithms. So just to refresh our memory, let's evaluate a couple logarithms. So we already know how to evaluate logarithms or what it means to evaluate a logarithm. So on this first one here, if we're trying to evaluate log base 2 of 16, remember that means we're trying to find what power do we have to raise the base to. So we're trying to figure out 2 to what power equals 16. And in this case, it'd be 2 to the 4th power. So when we evaluate log base 2 of 16, we get 4. Well, if we look at the next one, we have log base 2 of 27. So what this means is we're trying to do 2 to what power equals 27. Well, we know 2 to the 4th power is 16. That doesn't work. And we know 2 to the 5th power is 32. That also doesn't work. So in this case, there's not an exact number, but we can figure out it's somewhere between 4 and 5. However, there is a way to calculate something like this, and that's where we have to use the change of base formula, because unfortunately our calculator only has the base 10 logarithm, or the base e logarithm. So we need to know the change of base formula in order to be able to evaluate logarithms with bases other than 10 and e. All right, so the change of base formula says if we have log base b of a, so this can be any base, like a base of 2 like it is here, or a base of 5 or anything. We can change it to any other base that we want. Log base b of a is equal to log base c of a divided by log base c of b. So the a and the b are coming from our original logarithm. The base of the original logarithm is b, and then the number we're taking the logarithm of is a. Now this c can be any number we want, meaning we can change it to base 10 or base e, which is what we would want to do because those are the ones we have on our calculator. All right, so on these examples, we're going to use the change of base formula to evaluate logarithms. So this one is the one we were just talking about, log base 2 of 27. It means we're trying to figure out 2 to what power equals 27. And we already figured out there's not an exact number, so we have to use the change of base formula. This is in the form log base b of a. So the a is 27 and the base is 2. So when I use the change of base formula, I'm going to change it to base 10. So log base 10 of 27, that's a, divided by log base 10 of b, which is 2. Now, because it's a common logarithm, base 10, I don't really have to write the logarithm, and when you evaluate this on your calculator, you're not going to evaluate the logarithm, or you're not going to write the base of 10. You're just going to write it like this. Log 27, remember the fraction bar means divide, so log of 27 divided by log of 2. That's what we have to do on our calculator to evaluate this. All right, so I'm going to show you what it looks like on this calculator. You'll need some kind of scientific calculator that does logarithms, but you might just have to figure out how to enter it in your calculator. So I'm going to do log of 27 and then divided by log of 2. And when I hit equal, that's my answer. So it's approximately 4.75. That makes sense because we said 2 to the 4th power is 16 and 2 to the 5th power is 32. So it makes sense that the power would be somewhere between 4 and 5. All right, next one. We have log base 3 of 55. This is saying 3 to what power equals 55. And again, there's no whole number, so we want to get a decimal approximation. Since it's a base 3 and our calculator only does base 10, I have to change this to a different base. Again, I'm going to change it to base 10. You can change it to any base you want using the change of base formula. So this is in the form log base b of a. So when I change the base, I'm going to change it to log base 10. So it's going to be log base 10 of a, so log base 10 of 55, divided by log base 10 of b, which is 3. So log base 10 of 55 divided by log base 10 of 3. The base of 10 is our common logarithm, so we don't have to write it. So I could also write it like this. Log of 55 divided by log of 3. All right, let's evaluate that on our calculator. So log of 55 divided by log of 3, and we get approximately 3.65. So that means if I did 3 to the 3.65 power, it should be somewhere close to 55. Now this is an approximation, so it won't be exact, but it will be close. All right, next one. Log base 4 of 3. So this means 4 to what power equals 3. Again, there's not an exact power, so I can get a decimal approximation. My logarithm that I'm trying to evaluate is in the form log base b of a. So when I rewrite it using the change of base formula, it's going to be log base 10, I'm changing it to base 10 of a, so log of 3 divided by log of the base, which is 4. So log of 3 divided by log of 4. Again, since it's a base of 10, I don't have to write the 10. All right, so let's approximate that on our calculator. Log of 3 divided by log of 4, and press enter or equal, and it's approximately 0.792. We'll say approximately 0.79. All right, and then one more. We have log base 5, this is the base, of 3/4. So that's the a. Log base b of a is the form it's in. So using the change of base formula, it's going to be log of a, so log of 3/4 divided by log of b, so log of 5. So remember that the base is always on the bottom. So log of 5 is on the bottom. All right, so again, let's evaluate that on our calculator. So when I'm entering this, I'm going to enter the 3/4 in parentheses, so 3 divided by 4, and then log of that, log of 3/4 divided by log of 5. Again, you're going to have to figure out how to use your specific calculator to be able to do that. So log of 3/4 divided by log of 5. And when I hit equal, we get approximately 0.179. I'll go ahead and round that to approximately 0.18. Negative, whoops, almost forgot the negative sign. So log base 5 of 3/4 is approximately negative 0.18. So we do need to be able to evaluate some logarithms using a calculator that have bases other than 10. So we do have to know this change of base formula. All right. Now, these next properties are some basic properties of logarithms. We can figure these out without necessarily remembering all the properties, but if we know the properties, we can just figure them out a little bit quicker. So in all of these, the B stands for the base, and then the other numbers are just numbers. So on this one, we have log base B of 1. So it doesn't matter what the base is, log with any base of 1 is always 0. That makes sense because this is saying, if we're trying to evaluate this, this is saying B to what power equals 1. The only power would be 0. So that means, let's do these two practice problems. Number 1, log base 5 of 1. If we know the property, we don't have to do any math in our head, and we just can say this is equal to 0. If we're not sure, we can always figure it out. This is saying 5 to what power equals 1, and that would have to be 5 to the 0 power. All right, number 2 is log base 3 of 1. Again, the base doesn't matter. If we're taking a logarithm of 1, it's always going to be equal to 0, no matter what the base is. Again, because this means 3 to what power equals 1, and that'd have to be 3 to the 0 power. The next property is if we have log base B of B. So if these bases, the base is the same as the number we're taking the logarithm of, it's always going to equal 1. So log base B of B equals 1. That makes sense because if we have B, any base to a power, in order for it to equal B, it'd have to be B to the first power. So number 3, log base 4 of 4. Since these are equal, log base 4 of 4 is just going to equal 1 using the property, or we can figure it out. This means 4 to what power equals 4. In order for that to be true, it'd have to be 4 to the first power, 4 to the 1 power. And number 4, log base 6 of 6 is just 1. Again, this means 6 to what power equals 6. This would have to be 6 to the first power. All right, next property, log base B of B to the M power. The log base B and the exponential base of B are actually going to cancel each other out, and we're just going to be left with M, whether M is a number or an expression. That makes sense because this is saying B to what power equals B to the M power. In order for those to be equal, the power has to be M. So if we look at number 5, log base 2 of 2 to the 8th power. This log base 2 and this exponential base of 2 are going to get rid of each other, and this is just going to equal 8. Now, these properties we are going to want to know because that's going to help us when we solve equations. So we can also think about this logically. This is saying the base is 2. So this is saying if we're trying to evaluate this, 2 to what power equals 2 to the 8th. In order for these to be equal, since they both have a base of 2, the power has to be 8. All right, number 6, similar problem. This one has log base 3 of 3 to the negative 4th power. The log base 3 and the exponential base of 3 are going to get rid of each other, and this is just going to equal negative 4. Again, we can think about it. This, if we're trying to evaluate this expression, means 3 to what power equals 3 to the negative 4. Now, again, they have a base of 3, so in order for those to be equal, the power has to be negative 4. Now, the same thing applies on this last property. B is the base to the log base B of M power. So the log base B of M is in the power. This one, there's not really a way to figure it out like the previous problems, but we will have to know what this gives us. This, the exponential base B and the log base B are going to get rid of each other, and we're just going to be left with M. So if we look at number 7, we have 10 to the log base 10 of 30 power. So the log base 10 of 30 is in the exponent. So I have 10 as the base and log base 10 of 30 as the exponent. The 10 and the log base 10 are going to get rid of each other, and this is just going to equal 30. Same thing on number 8, 5 to the log base 5 of 14. The 5 and the log base 5 are going to get rid of each other, and we're just going to be left with 14. So these second two properties here, we're definitely going to want to know those because that will help us in our next section when we are solving exponential equations. All right, so we are going to stop there today, and we'll finish up this section for C tomorrow. Bye, everybody.